Welcome back to the channel. Today we're talking about text-to-speech, TTS projects. Again, I know, you're probably thinking, how many TTS tools does one person need? But hear me out, I've realized that human attention actually has tiers. When you're 100% focused, reading is way faster than listening. For example, even with a powerhouse like Notebook LM, I haven't even touched their audio or video features because time is such a scarce resource. If I'm researching, reading is just more efficient. But then, there are those times when your eyes are just tapped out. You're working on something, but you still want to soak up other info. Like when I'm reading comics, I'm not super focused, but you still have to use your eyes. Honestly, just staring at a comic feels a bit boring to me. So I usually want a magazine open on the side. What I really need is something to just read that magazine to me. Sure, there are products out there for the blind or those with reading disabilities. And they sound great because the audio is calibrated for a human tone. But for me, I just want to fill the silence in my spare time. I don't care about a perfect accent, as long as I can understand it, I'm good. It's like walking down the street. You hear all kinds of weird accents. And you just adapt to keep the conversation going. The problem is that most TTS tools, like Chrome plugins or Play Store apps, are weirdly hard to use. You'll be mid-article, and the app randomly crashes or unloads. And you have no clue where you left off. Or it won't follow your selection. To solve my boredom problem, I decided to just build my own. For the first round, I wanted a simple UI, a way to load content, a status check, and a play button. I also wanted it to handle URLs directly because copying and pasting text is a hassle. The goal was to strip out all the junk, ads, graphics, and page breaks that mess up the reading rhythm. By version 2, I realized I needed it to read local HTML files too. Sometimes websites hide content in frames, and only saving as from the browser captures the full text and structure. I also ditched the ugly system speaker for GTTS, Google TTS. Now, the program grabs one sentence, gets the audio from Google, plays it, and moves to the next. I also realized I needed a stop button and a way to track the current sentence number. Now, when you hit play, it starts exactly from the number you type in. The cool part is that if that sentence was already downloaded before, the app just plays the old audio file instead of wasting time grabbing it again. One little quirk, though, since my file naming system is super simple, if you switch to a new document without clearing out the old temporary files, it would dumbly play audio from your previous document. There are 3 big reasons for this setup. First, it saves bandwidth since we aren't constantly re-downloading stuff. Second, that download number acts like a bookmark, reminding me exactly where I left off in the magazine. And third, it prevents the app from accidentally eating up all my storage space if I forget to delete the old files. You might be wondering, why not just make it auto-delete files after a certain time? Well, there's a catch. For that to work, the app would have to be a resident program. Basically a background process that's always running just to check for old data. To be honest, most engineers hate that kind of thing because it constantly drains your system's performance for a minor task. I'd much rather keep it lean and efficient. Let's look at the WebView architecture. The main.py is ridiculously simple. It just opens a window and lets WebView do the heavy lifting. Let's take a look at the requirements.txt file. It's a pretty long list. The PyQt packages basically handle everything for the network interface and the simulated server. For the visuals, we're using WebView and Beautiful Soup, while the requests package does the heavy lifting for sending data from the front end to the server. And of course, there's TTS, which I'm sure you all know as Google's text-to-speech tool. Looking at this setup reminds me of a popular saying online. You have to work really hard just to look effortless. Because honestly, with WebView, you barely have to write any code at all to get everything running smoothly. Next, let's dive into appy.py. This is essentially how front-end and back-end development works. The front-end is all about the display, while the back-end handles the system control. Front-end tech has become so powerful lately that it can look amazing and even run its own local databases. So why go through the trouble of splitting the architecture into two parts? Because the user controls the front end. A user could potentially mess with the data on their end. And if the server just blindly accepts whatever the user sends, it's a massive security threat. For instance, if a user goes into their banking interface and types in that they have $20 million, the bank isn't just going to hand over the cash because the screen said so. Right? Another common issue is users trying to steal data belonging to others from the server. That's why anything that isn't strictly about the user interface is handed off to the server via an API. Take a quick look at what our simulated server is actually doing. It handles saving and reading files, processing text, fetching the TTS audio, playing it back, and even cleaning up those temporary files. Now, let's check out the user interface. It's all tucked away in the web directory. First up, the index.html file. This one's pretty interesting because I actually defined two separate pages, but the AI decided to merge them into one. If you want to see how it handles switching between those pages, we've got to look at how the load file button works, which means diving into the JavaScript. If you look at the script.js file, you'll see it adds a listener to the read button. Generally speaking, there are two ways a system scans components. One is a standard item-by-item scan. You see this most clearly in game development where objects are constantly moving. A more advanced way to redraw the screen is to identify exactly which objects are moving. That way, when the screen refreshes, the system only scans and updates the positions of those specific moving parts. Usually, we aim for a frame rate of 60 frames per second, FPS. For simple documents, 30 FPS is plenty. But if you're playing a first-person shooter, FPS, players are going to demand at least 120 FPS. In modern games, for the sake of visual effects, everything from the clouds in the sky to the leaves on the trees is moving. So the system really has a massive amount of data to scan all at once. So, think of a listener as an interrupt. Most of the time, you just let it do its thing in the background. It's totally hands-off. But the second it fires, it's a straight-up emergency. Now, if we want to dive a bit deeper, do these listeners have a line they have to wait in? Well, logically, yeah, they should. It's like the system has different queues based on how high stakes the task is. Pro tip: unless it's a total code red, you definitely don't want to be dumping your data into the intern queues. Keep the priority lanes clear. Alright, so tracking the read button. Basically, all it's doing is slapping a hidden state onto the class list. I mean, it is what it is, right? What else can you do? Next up, we've got to dive into the CSS file. Now, back in the day, style.css was really just meant to make the HTML look pretty. You know, organizing sections so they don't overlap, adding rounded corners, or tweaking the margins. But in the world of dev, if a tool works, we use it. So, we're straight up using display, none to control the entire page layout. Let's skim through this file real quick. Honestly, this is the part one find the most tedious. It's a total headache. You've got all these tiny details, exact pixel points, specific color hex codes, ratio math, and all these inherited styles layered on top of each other. It's just layers on layers of nesting. For a guy like me with basically zero aesthetic sense, all these tiny adjustments are pretty much invisible. So, that's a quick breakdown of the WebView architecture for you guys. I was really hoping I could just run this directly through the Python tools on my phone. But, big rip, QTPY just wouldn't install. Major bummer. Maybe down the road, I'll take a deep dive into Android app packaging, but we'll see. Anyway, that's it for today's video. Thanks for watching, and I'll catch you guys in the next one. Peace.